Hi everyone, welcome back to YouTube channel Vikasa Easy Learning. In this video, we are going to discuss about the decimal form of irrational numbers. So for example, irrational numbers are root 2, root 3, root 5, root 6, root 7, root 8, then root 10. We can't able to write root 9. So root 11, root 12, root 13, root 14, root 15 and root 16 is not there. So only we are going to take composite numbers and we are going to take what non-perfect squares here in the radicand place. So 2, 3, 5, 6, 7, 8, 10, 11, 12, 13, 14, they are all what? So they are not non-perfect square. You can't able to write perfect squares in the place of radicand. This is radicand place. In this place, we don't want to write perfect squares. Root 1, root 4, root 9, root 16. We can't write these numbers because if we have these numbers inside the root, square root of 1 can be written as 1 square. So because 1 into 1, it is 1 itself. 1 can be written as 1 into 1. 1 into 1 is nothing but 1 square. So instead of 1, if you wrote 1 square, then square and square root will cancel with each other. So then the answer will be 1. So in the same way, for square root of 4 is square root of, instead of 4, we can write 2 square. Square and square root can cancel. Then you will get 2. Therefore, square root of 4 becomes 2. It's a rational number. This is also a rational number. And in the same way, 3 square, instead of 9, 3 square, square and square root cancelled, then you will get 3. Then for root 16, we can write, instead of 16, 4 square, square root cancelled, root 16 is nothing but 4. 1, 2, 3, 4, these numbers are rational numbers. So that's why we cannot able to write perfect squares in this place. This place is called radicand place. In radicand place, we cannot able to write perfect squares except perfect squares. Whatever the number you write, there are irrational numbers. So therefore, if you want to find, this is what these numbers, if you have square root for these numbers, you can write the value, you can understand. Okay, 2, 3, 4, you can understand everything. But here root 2, you cannot able to understand. We need to write in decimal form. For example, root 2 value is 1.421 etc. This is the decimal value of root 2. How to get this? See here, 1.421 is nothing but everybody can understand. This is the number, it lies between, it is more than 1 and less than 2 because it is 1 point something. So it is almost 1.5. Everybody can able to understand. But here root 3, root 5, root 6, root 7 cannot able to understand. This form we cannot able to understand. It is difficult to understand. But this is easy to understand. Everybody can able to understand this if you wrote in decimal form. That's why we need to convert all these irrational numbers in decimal form. So we are going to use one method, that is division method, to find the decimal form of every irrational numbers. So we'll understand now how to find the decimal value of irrational numbers by using division method. For example, I am going to take root 2 first. So we need to write 2 here. What is the radicand? So we have to write that, and we should draw like this. So it is like just like a division. See here, we have to consider a number. That number, if you multiplied the same number, for example, I will consider 1. If you multiplied 1 with 1, whatever the number you consider here, the same number should be multiplied here. Okay. So 1 1 means you will get 1. That should be right here. The product of these two should be right here. So then this number must be less than this one. This product, what you multiplied and wrote the number, that number must be less than 2. Then only we can subtract this from this. So that's why we need to take that kind of number. For example, if you take 2, here also we need to multiply 2. 2 2s are 4. This is more than this. We cannot able to take 2. So we need to take 1 itself. Then that is less than 2. 1 1s are, you will get 1. So then we can subtract 2 minus 1, it is 1. So now here it is 2. 2 can be write as 2.00000. We can write infinite number of zeros, but there is no any change in its value. So 2 can be write as 2.000. So now I will take 2 zeros to take down. So here in this system, in this division method, we need to take down 2 zeros at a time. In division, we can take 1 zeros. Here, at a time, we need to take 2 zeros. So I have taken 2 zeros. While taking down, I need to write point in the quotient place. This is the answer. Quotient place, I need to write point because I am crossing point. So if you take down 2, then you have to write point here and 2 zeros. Then next, we need to add the same number what we have. Here we have 1, the same should be add. 1 plus 1, it is 2. Next, here you will get unit digit, this is. Then we need to increase this value to tens place. So you have to multiply one digit here. Sorry, you have to write one digit here. Then if you wrote 1, it becomes 21. If you wrote, if you are going to write 21 to, you can able to write 21 to 29. Okay, so whatever the digit you write to get this number, so that number should be right in the quotient also. For example, now I am taking 24, here also 4, 24 4s are 96. This is less than 100. So that's why I am taking 24 4s. Whatever the last digit you will write, the same digit should be expressed here. Okay, so then 24 4s are 96. Now you subtract 10 minus 0. You take borrow from here. So it becomes 10. Then again you take borrow. Then it is 10. 10 minus 6. It is 4. This is 9. 9 minus 9, 0. And you already taken this as a borrow. So it's 0 itself. So 4 left. Then again you can take 2 zeros. Okay. Now you should add the unit digit only. Here you added the total value. Whatever the number you taken, that number you added. In the next step, you need to add only the unit digit. Okay. Unit digit is 4. You must add 4 for this number. Then 24 plus 4, it becomes 28. So 28 now. Now you need to increase this value to 280 something. You have to write 1 to 9 here. So you can take 281, 282, 283 up to 289. So which is suitable for this? We have to consider 281 ones. If you taken 282 twos, that will be more than 500 and something. So that's why that is more than 400. We cannot able to take 282 twos. We have to take 281 ones. Then 281 ones are 281 itself. Now subtract 10 minus 1, it is 9. Here it is 9 already taken, 1 borrow. So that's why it is 9 minus 8, 1. Here 4 becomes 3. 3 minus 2, 1. 119 left. So for this 119, again you pull down 2 more zeros. Then you should add the last digit what you taken 1. So then next step will be 282. So for this 282, we need to increase one more digit now to get this. It is 11,900. Here if you increased, this value will be 2,820 something. 2,800 and something means it is almost 3,000. So we need to guess what if you wrote 3. 2,823 threes. It is nearer to this one. What is that? It is approximately we'll get for example 3 threes are, you just multiply. 3 threes are 9. It is nearer to this number. 3 twos are 6. 3 eights are 24. 2 carry. 3 twos are 6. 6 plus 2, 8. I think if you subtracted this, you have to check. So here it is nearer to this value. 10 minus 9 it is 1. Here it is already you have given a borrow. So that is 9 minus 6 it is 3. Here it is 8. 8 minus 4, 4. Then 1 it is not possible. 11 minus 8 it is 3. 3431 left. I think. So you can expect one more digit here. So you have to try and write 2824 forza will go, might be. So because it is very small, you are getting more number. So that's why we need to change the number. So here now multiply 4 4s are 16. Then 4 2s are 8. 8 plus 1 6, 9. Then 4 8s are 32. So 3 carry. Then 4 2s are 8. 8 plus 3 11. So this is the suitable number. Why? Because it is approaching this value. Whatever the previous number we multiplied, 23 3s are, that is too far from this number. So that's why we cannot able to take that number as how we are doing in the division. Okay. So in the same way here also we have to consider 11,296 is nearer to the 11,900 and 900. So you can subtract. So after you subtracted, you will get what is the 10 minus 6, 4, 9 minus 9, 0, here 9, sorry 8, 8 minus 2, it is 6, then 11 minus 11, 1 minus 1, 0, 1 minus 1, 0, you will get 604. Then again you have to take 2 more zeros and want to continue. This is the way of water. So these digits will not end, will continue. So you will get infinite digits. There is no terminating for the irrational numbers. But we can expect, we can guess the numbers. So this is the number which is what less than or more than 1 or in between. Means we can expect, we can understand the value. This is 1.414. So you can able to understand. So that's why this is the suitable method to understand irrational numbers. If you want to convert irrational number into decimal, so the division method, it is what a valid method. So you have to follow this to understand. Easily you can able to understand. If you are going to convert irrational numbers into decimal form, then everybody can able to understand. Therefore, it is useful. Have a look.